The last section of Chapter 10 is still comparing two means, but specifically with paired data. So this is going to be broken up into 3 videos. We're going to analyze the distribution of differences in the paired data set using graphs and summary statistics, and we're going to look at confidence intervals. Then there'll be a video strictly on significance test, and then one on determining when it's appropriate to use paired T procedures versus 2 sample T procedures. So our researchers studied a random sample of identical twins who had been separated and adopted at birth. In each case, one twin, twin A, was adopted by a high-income family, and the other twin, twin B, by a low-income family. Both twins were given an IQ test as adults. So here is the first pair and the 2 twins, the second pair, third, so on and so forth. And here are dot plots of twin A and then of twin B. So twins raised in high-income households had a higher mean, and there's a similar amount of variability between the 2 groups. But with so much overlap between the groups, the difference in means does not seem statistically significant. So the previous analysis that we've done in the second section of this chapter ignores the fact that these are paired data. So paired data result from recording 2 values of the same quantitative variable for each individual or for each pair of similar individuals. Think of this as back in chapter 4 when we were talking about sampling, we talked about matched pairs, or when we did sampling in experiments, matched pairs design. So here, the mean difference in IQ score is 5.833, and the standard deviation of the difference is 3.93. So here we have a dot plot of the difference between the twins. So one thing to remember is that the proper method of analysis depends on how the data are produced. So when do we analyze with paired data? You start by computing the difference for each pair, then make a graph of the differences, use the mean difference and a standard deviation of the difference as your summary statistics. So does music help or hinder performance in math? Student researchers Abigail, Carolyn, and Leah designed an experiment using 30 student volunteers to find out. Each subject completed a 50-question, single-digit arithmetic test with and without music playing. For each subject, the order of the music and no music treatments was randomly assigned, and the time to complete the test in seconds was recorded for each treatment. Here are the data along with the difference in time for each subject. So student 1, the time with music took 83 seconds. Time without music took 70 seconds, so the difference was 13 seconds. Here, student 6 took 106 seconds with music, then to 112 seconds without music, so the difference is -6. Notice that they're doing music minus without music. So make a dot plot of the difference in time for each subject to complete the test. Describe what the graph reveals about whether music helps or hinders math performance, and then calculate the mean difference and standard deviation of the differences, and interpret the mean difference. Here's a dot plot of all of those differences. There is some evidence that music hinders performance on the math test. 17 of the 30 subjects took longer to complete the test when listening to music. So the X bar in difference is equal to X bar of music minus without, 2.8 seconds. Then standard deviation is 7.49 seconds. So what does that mean? The time it took these 30 students to complete the arithmetic quiz with music was 2.8 seconds longer, on average, than the time it took without the music. So there are 2 ways that the statistical study involving a single quantitative variable can yield paired data. Researchers can record 2 values of the variable for each individual, or the researcher can form pairs of similar individuals and record the value of the variable once for each individual. It is also possible to carry out a matched pairs experiment using method 2. If the researcher forms pairs of similar subjects and randomly assigns each treatment to exactly one member of every pair.